Okay, picking up where we left off on page 419, we're finishing talking about in-house versus out-house solutions. So in-house does have some advantages because you're in complete control and perhaps you have some unique environment that you want to deal with. Package solutions on page 421, where basically they offer a turnkey. They'll develop the application for you, they'll put the web page together, they'll host it for you, they'll do absolutely everything. And you just pay them money and that's it, you're done. That is pretty attractive for an awful lot of companies. And then kind of the next one in the list is the service providers, where I just want to outsource bits and pieces. Let's, for example, that I don't want to host my web page local because of all the security issues. I want to keep my corporate network locked down as much as practical. So I don't want any place for incoming traffic to go to my building at all. So I hire somebody else to put together a web page at some other location, and then I might still have control. I might develop the software, the web page myself, and just upload it to the server. That might work. So you have scale. You have 100% in-house, 100% out-house, and then truth is probably someplace in between. It's where you have shared responsibility, where you're hiring out the things that you want hired out, and you have control over the things that you want control over. Okay. On page 421 again, they talk about the processing methods, batch versus online transaction processing, OLTP. And they talk about how that batch processing is still with us. Well, they're right. We still have combinations of people doing online, real, live data entry and batch processing. And the best example, and in fact, quite frankly, a heck of a lot better than the example they have in the book, is payroll. I mean, you're working at McDonald's. They don't interrupt you once an hour and say, here's $8. They don't even wait till the end of the day to pay you. They collect your time card, how many hours you work, and then at the end of 2 weeks or the month, I really don't know how McDonald's does it. Let's just say they pay every 2 weeks. So at the end of 2 weeks, they run a batch. They've collected all this data, and they run a batch and produce your payroll check. So that's a very good example of batch processing, where the data is collected but just stored, and then it's processed in one continuous chunk at some time in the future. So batch processing. Now contrast that to I'm on a web and I'm ordering a book from Amazon, and so I go in there and I fill out all my data, I hit the button, and it usually comes back with something that says we'll send you an email confirmation. I don't have to wait for the next day for that, do I? They didn't just store my information and like in the middle of the night they ran all those. No, that was live. That was live processing, because I got an email confirmation back saying, here's your order number. So that's honest to God, real live. Now, another scenario talking about time cards. There are businesses where workers have a portable data terminal of some sort, and they mark. Particularly people work out in the field. So you're a termite inspector, and so you're going from house to house to house on your little route, and you say, okay, I spent 4 hours here, and I spent 2 hours here, and I spent 4 hours here, and so at the end of so it collected the data, and maybe it even transmitted it directly. So you have live data, but when the client got billed for the amount of time, well, even though I collected it live, he didn't process the billing live. He didn't get a bill that immediate hour. Like, okay, I went to the Jones house and my portable data terminal says I spent 4 hours, and bam, they got sent a bill right then and there. Probably not. So yes, batch processing is still around. Online live processing is obviously around, and the combination of the two work just fine. There's no problem, no problem to find a solution for here. Leave it the heck alone. Okay. On page 425, they mentioned the OSI model, and if you're taking a networking course, you're going to go into great detail about the 7 layers and blah 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 blah. I'm not going to do that here. So let's just talk in general terms about network topology. Again, I think, my opinion, is the book kind of went a little too deep in this, because again, you probably have an entire another semester dealing just with network design. And so me spending 5 minutes probably doesn't do justice to a topic that quite typically is an entire semester's worth of work. So let's just talk network topology. And topology can refer to the physical topology, what it physically, or it could be a logical topology. And the classic example is a ring. You know, they have a ring topology. Do you really think physically that they have a cable that physically does that, you know, in a circle? Probably not. Probably the cable's laid out like any other cable. It's just that logically there is a loop involved. Not physically, but hey, that's the whole point. So on page 426, they talk about the hierarchical network. And this typically looks just like an organizational chart. Where, you know, you have the corporate headquarters and they have their LAN, and then the Chicago office has their LAN, and you know, spokes coming down, just like an organizational chart. And some people build these things like that because corporate wants to impose certain types of standards on the machines, and then perhaps the people in one particular area want to add additional controls on to that. And so this entire hierarchy scenario is exactly what, like, Microsoft's Active Directory system was designed for. It was designed for, you know, people at the top get to pick, people at the bottom get to make things more strict but not less strict. And there's some things you have to know about that, because if you have one particular area that has to have a different password retention policy than somebody else, well, then you need to know where password retention is in this hierarchy, and whether or not I can have it as an area down here, or does it have to be something completely different? Okay. The next one we talk about is a bus technology. In the old days, you know, you had Ethernet cable that looked like coax, like you have on cable TV. You had coax, you know, strung in the ceiling, and you had these drops that came out of the ceiling and hooked onto the back of your machine. And it was just one giant cable, and if somebody, you know, disconnected the cable because they were getting ready to install another machine, boom! Everyone from that end of the hall was screaming and hollering, "Ah, the network's down! The network's down!" It's like, just a minute. You know, so you make your connection and put it back together. Poof! Everything's back up again. So it really wasn't very robust, because any break in the cable and you were doomed, because it was just one giant cable running down the hall, so to speak, with things coming out of it. Ring technology, token ring is a logical construct. Does not mean physically that the cable looks like the diagram there. Anyway, it is still around. It's somewhat outdated, but that technology does still exist. The next one, talk about star technology, which is probably the one that almost everyone uses, where I have some sort of a switch, and then, you know, spokes of the star come off. And so if PC down at the bottom wants to talk to the other PC down at the bottom, it just goes up to the switch and comes back down. More than likely, in your house, you have a router. But it's not just a router. It's probably a router, a switch, a DHCP server, a DNS server. It is all these things. It's the central hub of your home network. Doesn't really matter if you only have one machine. It's still the central hub of your home network. It probably has a wireless access point feature too. So this one thing that we call a router is really 4 or 5 things all thrown together. Okay, so this is the predominant thing that businesses use, and there's some limits, you know, how long this cable can be, and those kind of things. But again, that's not for this course. The next one they talk about is a mesh network, where things all kind of talk to each other. Now, let me give you a strange example of mesh. Have you guys heard of the One Laptop Per Child program? OLPC? One Laptop Per Child was designed for rural scenarios where, let's say you have one kid who happens to live next to the school, and the school has a wireless network. And so he's within range. But the kid on the other side of the street is not in range of the school. But he is in range for kid number 1. And so kid number 1 just shares that network. And so it just keeps going. So the entire village, the entire town, can all be talking to each other and finding the way back to that one machine that has the internet connection to the world. And it's very robust, and you don't have to do anything. I mean, all you have to do is turn your machine on. And it says, okay, hang on a second, let me see if I can find the path to, and it just sits there and goes, hang on a second. It goes, oh, nope, okay, found it. And this is the path to the machine that has the network connection. So this mesh network is very reliable. If one piece went out, no big deal. Well, I'll admit, if the one piece went out that was connected to the internet, everyone goes down. But if a piece in the middle, so for example, I'm a kid in the middle of this mesh, and I turn my machine off, well, no big deal. It just routes around it all automatically. So mesh network is very cool and used a lot in wireless scenarios. Okay. Let's talk briefly about network devices, and I kind of mentioned the fact that the router, what's the proper definition of the router? Not the definition I just gave you where it did all these magical things. The proper definition of a router is that's the device that connects two different networks together. That's it. That's the real definition of a router, not when you go to Best Buy and look at the routers and all the gazillion things that it can do. I mean, don't get me wrong, they're routers, but they're routers plus a bunch of other junk. Then next they talk about network modeling tools, Visio, and a few others. Has some really cool tools that you can use to draw a diagram of your network. That'd be really helpful. Again, if I was a network administrator and the first day I came on the job and I said, show me the network diagram, the guy says, we don't have one of those. I'd say, wow, okay. I know what I'm going to be doing because I want to know how this thing's all put together. I need to know that, if building number 4 goes out, then building number 6 doesn't get network. I need to know those kind of things. Okay. On page 429, they talk about wireless networking. And most everyone's home now is done with wireless train. So here's kind of a list of some of the wireless standards. I'm currently using an 802.11ac router. To tell you the truth, I don't have any computers that can do AC yet. But I figured, well, what the heck, I will sooner or later. But so these standards are very slow to come and get ratified. But vendors basically come out and say, we're going to go ahead and start selling these things, and when the standard gets ratified, if there's a change, we'll just do a firmware update and we're good to go. So I'm not going to ask you any questions like, which one does 11 megabits? I'm not going to do that. So basically what you need to know is, the standards based, and heck, that's about it. Alrighty, let's continue. Okay, coming up next is we're kind of at the end of this design, so we're at the completion stage of our design. So again, let me just read some of this stuff that kind of points you to what's going to happen next. So system architecture marks the end of the system design phase of the SDLC. The final activities are preparing the system design specification, obtaining approval, and more than likely delivering a presentation to management. So those are the things that they're going to talk about next. So what is a system design specification? Yep, that's that document that represents the complete design. It's sort of like the decision paper. It contains everything you need to know about what's going on. Okay, this is coming up on the 15-minute mark, so this is probably a good place to stop. But we're almost at the end, so it'll be just a few more minutes after this one.